All right, we can probably get going. Hello and welcome to our Vicinity webinar, Analytics from the Frontlines. My name is Katie Finney and I work on the marketing end of things over here at Vicinity. I will be your webinar host and moderator today. And I just wanted to walk quickly through a few things. Steve will be hopping in the driver's seat here in just a moment, but really wanted to encourage everyone to keep the conversations going today and ask questions. You will have the ability to submit questions to our speaker through the Q&A section at the bottom of your screen, which will go directly to myself. And we will be answering them throughout the session, as well as addressing them throughout the Q&A portion at the end of the presentation. And secondly, yes, we are recording this presentation and it will be shared out tomorrow with you all. I wanted to quickly introduce today's speaker, Steve Wallow, Vicinity's Chief Technology Officer. Prior to working at Vicinity, Steve had served at the U.S. government as the Chief Architect for the NAVAIR Air Combat Tests and Evaluation Facility High Performance Computing Center, which is a total mouthful, for 15 years, as well as the CTO for Brocade, focused on federal. And with all of that said, I will hand that over to Steve and we can get rolling.
Cool. Thanks, Katie. So I guess I'll take the driver's seat here. So nice to meet everybody. I'm going to go ahead and stop the video so we don't have any disruption on the content here. So what we're going to do, we're going to walk through a little bit on some of the best practices for AI, specifically related to the federal government space. Okay, so we'll talk about a little bit on the company itself so you can see where the technology came from, but we'll dive into particularly the issue, right? What's the biggest problem with AI? What are some of the reasons this is occurring? So we'll talk about that. We'll show you how there is a different approach through our solution to kind of solve some of those problems, but more importantly, why it matters. Right? What does this open up? What does this allow you to do from a mission perspective, from an agency perspective? But more importantly, we're actually going to show it to you, right? So as we walk through this, keep in mind, we're going to show you some use cases, some examples of it in play here, but we're going to actually do a couple demonstrations so you can see it working, right? And then we'll finish up talking a little bit on the tech and we'll go ahead and answer some questions. Okay, so that's kind of the agenda for today. Real quick on the company, just to understand where this technology came from. This was bred out of the federal intelligence space, right? This was something that the NRO and NRL funded for solving some specific problems we're going to talk about, but it's essentially related to the fact that my data is not usually where I need it to be, right? And when you start thinking about some of the problems with AI as we walk through this, you're going to see that starts to be exasperated by current technologies, okay? So this is where the tech came from. There's a lot of patents behind this thing. There's a lot of different ways to get to this, but it was bred out of this high security environment. Okay, so that's where the genesis of what we're going to show you came from. Now, fundamentally, if we think about this from an AI perspective, right, what are some of the biggest challenges with AI, right? It's the new thing. Everybody wants to do it. People are kind of dabbling into it a little bit. As you start walking through AI, you start to realize that there are some big challenges that we have to work through. I kind of highlighted three of them here. One is, we have to train the model. And when you start thinking about, training these large language models and other things, it usually involves tons of data, right? I need to be able to push a lot of data to train this model. And anytime you start moving a lot of data around, that relates to time and cost. So we can improve the efficiencies of that. Well, then we might be able to help this, number one. Two is we want to make sure that we're getting accurate and relevant input so I can get a more accurate output, right? The last thing I want to do is be looking for a tank and end up with a white kitty cat or something like that, right? So the idea is, I want to train the model, but I want to be able to tune it and do some unique things so that I can have a feedback mechanism to say, okay, I think I got this correct, but how do I enhance it? How do I get more accuracy out of that? How do I remove hallucinations, to get me the result that I'm looking for? And then the last one here, it's labeled as resource agility. And we really see this in the Fed space, right? There's a lot of infrastructure in the federal government. There's a lot of it that is very hard to reach. A lot of it is kind of outdated, but how do I go ahead and leverage that? But more importantly, how can I grow my mission into using AI without vendor lock-in, right? I want to have agility and the resource of choice to do different things with some of this more modern technology, and that's what we're going to show you, okay? Now, think about this. Okay, what is the AI utopia? And in fact, does it actually exist, right? So if you think about it, and then I apologize for my little stick figure drawings here, but fundamentally, this is kind of what we're looking at, right? We have an AI engine that's out there. It usually takes a good bit of horsepower to make that go, but we're going to talk about some AI at the edge as well. And then, of course, I have my data. And again, we talk about training that. There's some software tools that we're going to apply to this. There's tons of them out there. They do different things, but we want to be able to leverage those. So the utopia is, okay, I found a compute platform. I have an engine of choice. I have my data sitting right beside it. I put some tools behind it. I get a work product, and hopefully I get a really good user experience and the result that I'm looking for. Again, if I'm looking for a tank, I want the tank. I don't want something else. Okay? This is the utopia. Does this exist? Well, not exactly. And here's why, is the fact that fundamentally, my data is probably not sitting by the AI engine that I want to use. If I want to leverage a core data center, if I want to leverage a cloud, need some big horsepower to go ahead and drive this, my data is probably not there. There might be some of it, but the origination of that data is usually somewhere else. And it takes time to pull that in. That was the training aspect that we just mentioned. So all of a sudden, that little pink brain on the bottom is starting to have a little bit of stress, right? And then if you think about it, well, it's not usually one piece of data that I'm interested in, it's lots. And they're geographically distributed. Again, the more data that I can put into the training element, the better I can get a result, right? And I want to have diversified data. So I'm not usually pulling data from one particular source. I'm pulling data from multiple sources. So fundamentally, number one, if I can speed that process up, if I can train my engine faster with more data, more diversified data, and I can get it in there in an hour as opposed to a week, all of a sudden I'm going to get some more interesting results. Now that's all well and good, but remember there's that second side of the piece here, which says, okay, maybe I have nested AI, right? As we start looking at advancements in AI, you're going to start to hear things like distributed AI or nested, meaning I'm going to train a model and then that model is going to feed something else. And maybe all these models will start working together and give me different aspects that I can pull information out through that process, have things running in parallel. And there's a lot of different things you're going to see as we walk through this kind of AI workflow over the year that we're going to start to do some advanced things. So all of a sudden, this single engine becomes multiple engines across multiple different regions, working on multiple different data types. But guess what? I need to have a feedback mechanism. I need to be able to say, okay, am I getting the results that I want to, right? So how do I get more advanced features, and how do I get more efficiencies through that? Well, that's where we start looking at things like, if you heard a term called RAG, right? Retrieval augmented generation or something like that. It's this concept that says, hey, I've trained my model. I put as much data from many diverse sources into the engine. And now I want to be able to tune it with stuff that's happening in real time, right? That's the whole idea behind what's really going on with RAG and some of these other technologies, which is let's augment it, let's tune this model based on occurrences that are generating constantly against the primary data that I put into the model. So all of a sudden, this utopia has a lot of issues, right? As I walk through the technology that we're going to talk about today and some of the solutions, we're going to try to solve this problem or at least minimize the negative effects of it. Okay? Now, a couple things about this, right? If you think about the input to my AI algorithms, right, especially in the federal space, there's a lot of different things around this. But some of the biggest ones, you see three of them here, right? One is the sensor data. And these are, what is a sensor? There's a lot of different definitions of a sensor. It could be an airplane, right? Big computer with wings, pile of sensors on it, sea platforms, mobile platforms, body cameras. And you see here as security and cyber, right? One of the other things that related to the sensor is it could be a virtual sensor or a software-based sensor, right? I'm monitoring what's happening from a cyber event to see what's going on, right? And which could be millions of different endpoints that I have to pull together that are all geographically distributed, especially in the Fed space. This is a worldwide thing, right? How do I get all that kind of information into the model in a different way? Then, of course, we have the surveillance data, right? If you think about FBI, if you think about, people looking at network activity and application monitoring, right? I want to see what's going on. Are there hackers and other things out there doing different things? How can I track that? And I want to be able to make sure that I'm doing it, as you see here, the term in event, right? The last thing I want to do is be monitoring things for malicious activity, and then all of a sudden I get to it, but I can't really see it. I know something's happening, but I can't get the data that I need because it's too far away, right? If I can pull that data faster, then I might be able to do things in event or as they're occurring. That's what we're after, right? That's one of the powers of AI is remove the human component, let the AI engine do it at the speeds that's possible. But if I'm starving it with data, I'm not actually doing anything in an event. I'm still back to the same problem of waiting around, right? The other piece is it's geospatial imagery. And the reason we show this one is there's a lot of distance. When we start talking about satellite, that's that's not just 1,000 miles away, right? There's a lot of distance, a lot of latency with these images, and they do a lot of different things, right? It's the combination of a lot of different data types that we're fusing together to feed that AI algorithm or to tune it, right? That's really what we're talking about here. Now, what is the biggest problem with all these? Distance, right? You heard the term latency. My stuff is all over the place. And what's the underlying culprit? Well, it's actually time. So what's working against you, aside from budgets and things like that? It's your adversaries, right? If they can, do things that are faster than you can pull the information back to do something with, they have the upper hand. So how do we change that, right? If you think about this, why is this important? Well, do you see the big picture of the map up there? If I can't get the data, guess what? I got no output. Pretty simple stuff, right? What if I get the wrong data, right? What if my tank that I'm looking for all of a sudden starts squirting out algorithms that are, images that are of Katie's white cat here, right? So, this is a big problem. The other thing is, there's a perishability with data. You guys see this in the Fed space a lot, right? There's only a certain limited amount of time in some cases for me to get the results that I'm after. Otherwise, the data has changed. Now I'm constantly working with old copies, which means I'm constantly getting old results, right? Now, the other piece is, what can this cause? And if you think about this in the Fed space, these are very common complaints, right? This is something that is prevalent throughout a lot of different agencies and missions and intelligence communities and Department of Defense and things like that. It's one, what can this cause? If I can get my data fast enough, faulty decision making, right? And in some cases, this is life and death, right? If I can't get the information that I need, in a time frame that I want, can I storm that hill? Can I put a platform in the air to do something with it? I want to make sure that I have low risk and maximum effectiveness, right? The other thing is this workflow disruption. If you think about this, if I get the wrong results, I got to go back in and do it again. And, that could be a very arduous piece related to cost, related to time, or related to actually getting insights into what's happening in the Fed space. And then the last one here on the right-hand side, which kind of relates to that resource agility, is the incurring cost, right? There's a lot of infrastructure in the Fed space. We want to make sure that you can leverage what you have, but how do I make sure that I'm not locked into one piece? Maybe I want to use a cloud. Which cloud? Maybe I want to use a core. Well, which core? Maybe I want to leverage some edges. Well, which edges? Are all of them? Some of them? How do I pull this all together? That's what we're really after here, right? Now, the utopia of what we're trying to do here is this. You need a solution that says, all right, I'm going to create a continuous data pipeline, nice little term, that's going to glue the cloud, the core, all these edges together. But a couple of things have to happen. One, I want to stop waiting for the data, right? Whether I'm training the model faster or I'm augmenting it with this RAG product, this tuning of real-time information as it's occurring. Two is, I want to stop manipulating the data. If you think about the way that a lot of the kind of like older technology has been around for a while, there's lots of them, move information around. It's a lot of touching the data, meaning I'm going to do things like compression, I'm going to do dedupe, I'm going to make the data look smaller so that I can essentially move it faster to kind of help solve this problem. And what we're seeing is that in some cases, that is a big problem, right? For example, let's say we have an image and, I can go ahead and compress, I can do different things, and I send it to an analyst and the human eye can say, okay, I don't see any changes. Everything looks good. Let's annotate it, do whatever in the world that we do. The problem is if I throw a compute platform at it, an AI algorithm, well, the human eye might not be able to see things, but the AI engine can. And one bit that might be manipulated in the wrong way can make a big difference, right? Or maybe there's regulations or compliance that says I really need to work with a pristine copy of the information that I'm getting. And I need to make those pristine copies from all over the place. So this manipulation of data is starting to become a problem, right? And then another one, of course, is, am I losing data, right? There's a lot of remote infrastructure out there. And what happens if I start moving or losing pieces of it, right? I'm getting incorrect information because I don't actually have consistent data that I'm putting into the model, right? So that being said, this is what we've created. It's this idea that I have, it's affectionately this intelligent data mesh, but it's this idea that says, okay, I have the agility now to pick the resource that makes the most sense for me to use to do the work that I need. And that is very, very powerful. If I want to use a cloud, which cloud? Well, I don't want to be locked into one. Let me use the resource of choice based on performance, cost, capability, something like that. I want it to be my decision, not based on data region, data locality. It's closer to the data or whatever. And I don't want to start with one and then be locked into that. So we can give you the flexibility or the agility to choose the resource you want and then point it to wherever that data or data sets reside. And then maybe one cloud of data is in a different cloud. Maybe it's on one edge, remote edges, lots of edges, all that stuff glued together. The idea is I want to have everything look and feel like it's all within the four walls of a data center. And if we can do that, where we're virtually creating this four-wall environment, but stretching it physically across the globe, that is very, very powerful. And that's what we're going to show you today. All right? Now, why does this matter? I'm going to show you a couple examples of this in a minute, and then we're sure to do a demonstration here. But this is really why it's important, right? I need to be able to streamline my decision-making. I want to create a paradigm where I have less risk in the process. I can do it faster, right? The whole idea behind what we're trying to do in the Fed space, whether it's AI for document investigation, whether it's AI for video analytics or troop movements or whatever it is, I want to streamline that process, right? And secondly, I want to extend my data reach. I don't want to limit myself to getting only the data that I can get in time. I have this really good information that's really, really far away. I wish I could get to it, but I just can't get it in time. I can't wait. I have to make a decision. Well, if I can extend that data reach, leverage these remote locations of infrastructure and architecture that the Fed space has. I've been in the Fed space a long time. There's a lot of stuff out there. If I can extend it to actually include everything that I've ultimately paid for into my decision-making paradigm, there's value there, right? And again, we've talked about just resource agility. Right? So what does this mean to your mission, right? Well, one is I want to reduce my hallucinations, right? I don't want the kitty cat. I want the tank, right? The other thing is I want to increase my data diversity, right? And this whole concept of RAG, right? I don't want to create, more efficiencies. I don't want to have to pay for more infrastructure. I want to use infrastructure that I have in a more efficient way. That's what this is about, okay? So let me give a couple examples of this in play, and then I'm going to show you the demonstration. Right? So these are real numbers, right? So we talk about training the model. Like, look at the first piece of it. How do I get more data into that model? How do I get it faster and more of it? So in this case, what we've done is we said, okay, I have a 1 gig network. We actually did this. This is one of our customers. And we said, okay, how much data can I move from the East Coast over to the West Coast, right? In this case, it was saying, okay, how long does it take to move this terabyte of data on a 1 gig network? And people always want to do a comparison. We're the little company that does a lot of things in the Fed space that nobody's ever heard of, right? So they say, okay, let's try, get a baseline. What am I doing now? How's it work? Does it, what I'm leveraging the existing stuff that I have. And they were moving this terabyte in a little over 10 hours. We put our software in. It's just software. I'm going to show you that. But essentially put that in and we moved it down to a little over 2 hours, 2.4 hours. Okay. And if you extend that over the month, because a lot of times it's like, okay, well, I have more than a terabyte of data. How much data can I move in a month? And without us, it was about 71 terabytes. With us, it was about 300. So fundamentally, I'm able to feed the AI engine more data, right? That's really what this is about. Small little data sets, small networks. So then what we did is we said, okay, let's actually take it to real world, right? Some of the folks in the Fed space, you guys out there, there's tons of data. Terabyte of data is not a lot of data anymore, right? Petabytes of data are more prevalent. And so we said, okay, well, we have a 100 gig network. And we actually did this, right? How much data or how long does it take to move a petabyte of data, in this case, from the East to the West? And instead of multiple days, it was actually a little under 24 hours, just 23 hours and some change, right? And if you think about that per month, because a lot of times you say, okay, I have more than a petabyte. We've actually seen this. Without us, it's about 7, but with us, it's 30 petabytes. That's a big difference, right? So again, what we're showing you is, hey, just the simple concept of I need to feed data faster for training. Regardless of where that data is located, I'm going to be able to do it a lot more efficiently. Okay. Now, the other side of that coin, so there's kind of two sides of the vicinity coin. One is we're going to move data fast, right? We're actually going to do it without touching the data. That was part of the design goals, right? But two is this whole concept of, well, maybe I can augment my trained model with something in real time. And the only way that works is if I can remove this paradigm that's been out there for years that says, well, in order for my applications to perform well, I got to have my data beside my app, right? If I want to run the AI engine, I got to have the data beside it. Well, maybe not, right? And what we've done is we've shown that you don't have to do that. Maybe you can augment just this brute force pushing data in with this really nice approach. It says, hey, let's take my application in one spot. Maybe it's the cloud. and have it work with information that's thousands of miles away in real time, even with a high latent WAN connection in the middle. And that's what we're showing you here, right? So the chart here on the right-hand side is pretty straightforward. What we did is we said, okay, we have an analyst, and this is actually one of our other customers, right? We have an analyst in DC that wanted to look at a data set that was in Hawaii. And that the app took about 15 minutes to run, right? There's terabyte of data, on a 1 gig link. And at the top, you see on the right-hand side, this normal workflow. So the blue bar is how long did it take to move the data, in this case, 16 hours. And then it took 15 minutes to run that application. That's the standard workflow. Then we put our software and said, okay, well, let's change that a little bit. Let's go ahead and speed up that data movement. So we took it from 16 hours down to 2. And okay, that's great. 16 hours down to 2 is a major improvement. Of course, then you have your 15 minutes to run that application. And at the bottom, we said, well, let's create a different approach. Maybe don't move the data, just run the app remotely against the data or data sets that are out there in real time. And we did that. It took a little bit longer, 18 minutes. However, what you've seen is 16 hours down to 18 minutes. One of the things we always tell folks, the technology is cool. We can go to the technology if you want, just give us a shout, right? But what's really important is what you can do with it. What we're showing you is a completely different approach to solving a problem. What we're showing you is the ability to do something that you didn't think was possible before. So it's not the technology for technology's sake. It's showing you from a mission perspective, whether it's my agency, my intelligence community, my DoD, I'm going to start being able to do things or look at doing things that I never thought possible with remote information, right? So let me give you a couple examples of this. I think I have 3 of them here, right? This is one of them. Said, okay, I want to do something with geospatial imagery, right? The folks that are doing something with it are usually CONUS, and guess what? The data is not. The data is usually somewhere maybe in theater. And what we were seeing is, okay, the standard process is I'm going to take the data that I've collected in theater, this imagery data, and I'm going to move it to be close to the analysts in the U.S. And it was taking, in some cases, it takes almost a day to do that. In other cases, we've actually seen people pull hard drives and throw them on planes and carry them around, right? It's kind of interesting. And then, of course, a little bit of time to run the analytics behind that. What we did is we said, okay, let's change the workflow. Let's actually just have that AI application reach across to in theater where that data has been collected and is sitting there ready to be looked at. Instead of moving it, just go ahead and work with it. And, the number here, 39, 30x faster, that's pretty good. What we're showing here is faster sensor to shooter timeframes, right? If I can start looking at data in a different way, 24 hours to 22 seconds completely changes my mission, right? That's a whole different approach. That's what we're bringing to the equation that you as federal folks have to deal with, right? Another one here. This is actually kind of cool. This is, if you guys don't know what this boat is, you probably do if there's any Navy folks on the line. This is Stiletto, right? We actually did some stuff with this. And this was actually, one of these cases where you start out with satellite and then you end up on the internet and then you go over some hotspots and all these kinds of things. The reason we bring up this case study is, one, it's faster time to action for, sensor platforms at sea, right? But the reason that this is kind of cool, and it's one of the nice things about the technology that I'm going to show you, is we don't care what the mechanism in the middle looks like, right? From a technology perspective, we're just an IP package like everything else on the network. But what happens is, if you look at the architecture that you're working with for your mission, you might not own all of it, right? Some of it might be adversarial. Some of it might be borrowed from something else, right? And if I don't have to worry about, having complete circuits under my control end to end, but I have the ability to use other things to reach remote pieces of information from a federal perspective, there's value there, right? And if I can do it in a kind of obfuscated way, all of a sudden now I can pull information in to feed or tune my models, with that reach that we talked about, where I might not own or want to be aware, have other people be aware that I'm doing that, right? That's one of the reasons we showed this one here. The last one here, this is kind of cool. This goes back to that theme of, hey, before what I'm going to show you with our solution, they were hand carrying things around, right? If you think about the jet, some of our FSI work we do, right? Tons and tons of information, 100 terabytes plus being collected off these air platforms, flying around, big computer with wings. And there's a ton of information that comes from that. It's essentially a big centrifusion platform, right? I need to take that data. I need to get it back to, in this case, it was back to the engineers that were saying, okay, did this work? Did I correctly assign the right resource on the platform to take care of the threat that was there in front of me, right? How do I augment that? How do I do more innovation associated with that. Now, if I have to wait for that data to get to me because somebody has to grab it from a shuttle and put it on a C-130 and fly it out to where I need it to be, there is a lot of time frame, a lot of inefficiencies in that process, right? So we were able to do that in 40 hours. We definitely met the requirement. But the reason I show this again is because one, it's in a highly classified environment, but two, again, it's showing you the ability to do something different, right? It's what we're doing is we're trying to help people think differently, not just about AI, but about how you can leverage remote resources in that AI platform, okay? So here's what we're going to do. I'm going to show you the demo. We're going to do, I think 2 or 3 of them here. They go pretty quick. But a couple of things about the technology itself. We're not sitting here talking about the tech, but there are some design pieces I want to make sure that people grasp as we started talking about what's possible, especially from an AI platform here, is, we want to make sure that we can drop this in without having to change a lot of the architecture, right? We'll always tell folks, hey, I can give you the greatest things since sliced bread, but if you have to change your applications, your network, storage, all that kind of stuff, there's no value. It's too costly to put it in, right? Some people say the juice isn't worth the squeeze, right? So a couple of things. One is, as you walk through this, there's no wide area network changes you have to do, right? The technology is based on some unique things, but we wrap it in what looks like a normal network packet going down the wire. So no changes to the wide area network, no changes to the LAN or the storage. I want to leverage the storage that you have, right? And also want to make sure there's no application changes, right? Compared to the commercial space, usually Fed applications are, outsourced to primes, and making any sort of changes to applications becomes very costly. It's almost to the point where you just find another way to do it, right? So if I can give you a solution that you don't have to change those types of things, there's some value behind that. Two is, want to leverage some unique things from a protocol perspective, but we want to make it look like everything else. Two, want to make sure that we don't break the security paradigm, that we augment it. So when we do this reachability or this massive ingest of information for things like training, we want to make sure that, we're putting a unique security paradigm on top of what you already have so we can enhance that. And again, we already talked about this. We don't want to mess with the information at all, okay? So here's what's going to happen. The way the demo works is we're going to show a comparison. That way, if I give you a number, say, is that number good or bad? Well, I'm going to show you a baseline number, then you can see the difference, okay? The way that the demonstration works is for the compute platform, we're actually using the cloud. It could be a core data center. It could be an edge. This is bidirectional technology. But for the demonstration today, we're just using the cloud. This is specifically AWS. It could be Azure, Google, OCI, anything like that. But we're actually using AWS West. And this is specifically West 1. So this is in San Jose, Santa Clara, California area. So that's where my applications are sitting, right? The data, however, that we're going to use for the demonstration is actually on-prem. And this is in our office right outside of Washington, D.C. in Germantown, Maryland. So what I'm doing is I'm literally separating the compute, the applications, from the data by East Coast to West, almost 3,000 miles. What we haven't done, just for technology's sake, is we haven't taken a copy of the data, pre-moved it, preloaded it, pre-cached it. We're literally separating compute and data by coast to coast, okay? The only difference between the Vicinity solution and the traditional approach is this little white circle with a rainbow V. That's our software, right? It's a bookend approach. I need something by the data that you want to share out. We'll show you that in the demonstration. And I need something by the consumers of that information, whether it's an application or another data store. I'm showing point to point, but we can easily do point to multi-point, but we're keeping it pretty straightforward here. All right, so let's go to the demo. Now, what I have here, this blue window, what I've done is I just logged into that Vicinity instance that's up in the cloud. And we're going to do some things. I want you guys to see the value behind this. Again, it's not the technology, it's what's possible, right? So the way the technology works, meaning what does it look like, right? People kind of get it. They're like, okay, I get you're moving data faster. You have this concept of this remote access, this ability to access the data over distance, which is kind of different, kind of cool. And you're going to do it without making a lot of changes to the architecture. But what's it look like? We look like a storage device. We're not storage. We want to be storage, but we want to look like one. So here's what happens is from this instance, this laptop, this server, whatever you want to call it, right? What I do is I'm showing you a file-based demo, by the way. We also work with S3 and Object. In fact, we're actually we're the only company that works with the new S3 Express One Zone stuff out of Amazon. But we're not showing it for the demo today. It's just file. But so here's what happens. From this laptop, this server, this instance, I just create a folder. I create a network share. And I point it to that Vicinity piece of software that's sitting in my environment. Okay? We're not an inline thing. We're just a piece of software that sits in the environment. So a couple of things from a value perspective, right? From a mission effectiveness perspective, think about this. If I look like what you see here, right? I click on this folder and up comes what looks like data. Cool. Not really. This is actually the pointers or the metadata of the physical data that's still 3,000 miles away, but it looks like it's here. So think about this. From an application perspective, all I have to do to my application in order to use this new approach to solving these problems is just say file open, and I just point to a different folder, a different mount point, a drive letter, a B drive. This is what we have here, right? So there's no changes to the application except just file open and point to something else, right? So you save costs there. Two is that this is something that's very easy to understand. Files, folders, and shares. Most people know how to do that. It's baked into the operating systems of almost everything that you have, even your cell phones, right? One of the biggest problems with new technology in the federal space, you guys have seen this, is it could be really, really cool technology, but if it requires a lot of training to put it into the environment, there's not much value there. That's extremely cost ineffective, right? It costs a lot of money to do this training. And oh, by the way, usually what happens is you train folks and they get deployed somewhere else, right? It's a very horrible process. So we can streamline the operational cost for technology insertion, then all of a sudden there's some value. That's what we're showing you. You know, we can teach somebody how to do this in about 2 minutes, okay? The other piece is there's no license that you put on this instance, this laptop, this server, right? Most things have the ability to create files, folders, and shares. That's just part of what everything has now. So from a cost perspective, there's only one thing. It's just that software that's sitting in each location, and then all the other users could be 5, 10, 20, 100 can point to that software and leverage it, right? So again, it's all about operational simplicity and cost reduction. Okay, so that's what it looks like. I also have here this gray window, which is kind of the traditional approach. So again, we're going to show a comparison. So I'm going to show you a couple of things, right? One is let's just move some data, right? First side of that coin. Let's get data into a AI training model, right? I don't have a model sitting here, but I'm going to show you the data movement, and you can easily extrapolate. Oh, okay, that could feed my model a lot faster, right? So we'll do a comparison. So what I have here, I have a bunch of 10 gig files. We're just going to pick one, right? These are just random numbers. Again, we're not about touching the data. We'll just pick, I don't know, let's say number 7 here. We're just going to drag it from the East Coast to, in this case, the cloud. And I could easily be pulling it into a model to do some AI training. We're not going to spend a lot of time on that kind of stuff, just for the essence of time, right? But what you're seeing here is I'm doing a 10 gig file move from east to west, and it's taking about 20 minutes, and it's running about 8 megabytes a second. Right? And oh, by the way, this demo is using the internet. And you can define how much bandwidth our solution use. I think we're setting at about 700 megabits, something like that. So 20 minutes and about 8 meg on that transfer. If I do the same thing from the Vicinity side here, right? So same data, same network, same instance type, same storage, everything exactly the same, except we're just kind of tunneling through our software in and out of the door. Well, instead of 20 minutes, I'm down to about 2. And instead of 7 or 8 megabytes a second, I'm at 77, 78 megabytes a second, right? So fundamentally, if I need to move data from anywhere on the planet into the environment that has my AI algorithm so I can train the model faster, or whatever in the world you want to do, this is showing immediate value, right? It's pretty straightforward stuff. It's easy to understand. One thing that's kind of unique, I do want to show you this, right? This is one of our management tools. The reason I bring this up, if you look at the green circle on the bottom here, it says 97%. What this is doing is it's monitoring the throughput, the efficiency of how much data I can put on a circuit of the amount of bandwidth that I'm able to use. And what you're seeing is we're hitting, 96, anything 90+% of whatever bandwidth I'm allowed to use. If I can use that much on even just a single flow of data, which you're seeing here, those are pretty good efficiencies. And oh, by the way, that efficiency is very similar to what you would see on a local area network within a data center. But I'm actually doing it using a wide area network. That's what's very different. Right? That's what I've shown you on some of the case studies that we're able to do. It's our ability to sustain throughput equivalencies or efficiencies that are pretty much equal to what you would find within a data center, but we're doing it over large geographies. Okay, so we're going to go ahead and stop that. I'm going to wait for the paint to dry on this one, definitely. So now that we've created this kind of global local area network, let's do something with it from an application. Remember, the second kind of bullet of this AI utopia was the ability for this AI engine to actually do something with data that's over distance in near real time. And that's what I'm going to show you here. So we don't care what the app is, right? We're just look like storage, well, whatever app you want at it, right? So this application, so we'll do a couple here. We'll start from more of a intelligence DoD perspective, right? What we're going to do is we're just going to bring in some geospatial imagery, right? So this is just a simple geospatial viewer. The underlay here is San Jose. What I'm going to do is I'm going to start on the traditional side, and I'm just going to bring in a tile. In this case, it's called a raster image, right? We're going to start on the traditional side, and we're just going to pick one. So I'll just pick this little TCI one at the bottom, whatever in the world that means. And I'm going to say add and close. Now, remember, this data is 3,000 miles away from where my application sits. Now we're going to come back over here to the vicinity side. We're going to do the same thing, right? We're going to go ahead and pick that TCI one, again, whatever that is. Say add and close. So think about this. If I want to use an AI algorithm, all of a sudden have instant access to that information. You see the tile pop up, right? And, we can do different things. Like I have the algorithm start working with it. We're over here. We go back to the traditional side. This is the problem. Right? The blue spinning circle. I'm not getting the data that I want and any sort of time frame that I need, right? That's why we're kind of without vicinity. What you would do is you would normally, we're going to close this, you would normally make a copy of the data and you would put it close to where that compute and application resides, the AI engine, so that I can work with it without having a performance problem, having to go get, 9 cups of coffee on lunch before I have to come back and have a result, okay? So now let's do something, let's look at it from more of an agency perspective, right? Let's do something with medical imagery, right? There's a lot of vet space that are doing some stuff. So I'm going to do here, let's do something with COVID, right? That's always interesting. So what I have here, this is just a DICOM viewer. It's a type of imagery that's used a lot in medical spaces here. What I'm going to do, we'll start on the traditional side, and I'm just going to bring up a scan, right? So what I'll click on in these zip files, and you see I have COVID scans. So we're just going to double click one. And we'll come back over here to the vicinity side, and we're going to do the exact same thing. We'll pick the COVID scan here. And again, there's a lot of AI related to healthcare life sciences, right? I'm looking for a lot of different things, whether it's imagery, genome sequencing, something like that, right? If I have the ability to actually go in here and start working with remote information, there it is, popped it up, right? If we come back here to the non-vicinity side, this is a problem, right? Looking at remote images, whether it's medical imagery, satellite imagery, something like that, is, there's a lot of relevance in the federal community. And what you're seeing here is why traditionally move stuff around, right? Because of this. So let me show you one more thing here. So we'll kind of keep on this video theme. We'll go ahead and try to stop this. See if no, there we go. It's funny because, a lot of times you can see the difference. And sometimes what happens is the application, the AI algorithm, whatever, just doesn't work. Right? Again, we're showing you something that you didn't think was possible, but now is. Okay. So the last one here, what I'm going to do is I'm just going to bring up, we're just going to play a video, right? And again, this one's cloud-based. It could easily be running on another edge or a core. You could do, edge-to-edge data fusion. What if I wanted to do edge AI, right? That's pretty cool. There's a lot of different ways to do that, especially for things like curating the data, doing some pre-filtering. But I usually want to do something with that data that I just curated, that I've done something with. I don't want to have a stranded edge. I want to link it back to the mothership before I can look at all the edges that are doing some kind of remote AI. So again, we talked about that nested AI. It's this complementary relationship where now what I'm doing is I'm empowering the edge so that I can leverage it, but I can also use it in part of my decision-making paradigm on almost real time. Okay. So what I have here, this is Adobe Premiere. I'm going to just bring in actually have a little drone footage here. So you start on the traditional side. There we go. We're just going to bring it into the tool here. We'll do the same thing on the vicinity side. Okay, and I'm just going to play it. Now, because we're on Teams or Zoom or whatever the world this thing is, what I've done is I've turned on some math. I've turned on some metrics here in the middle. In fact, let me make it a little bigger so you guys can see it. And you can see in the middle it says total and dropped, right? Premiere can keep track of the frame count. We can do a lot of different things. With a lot of our customers are doing analytics on imagery. That's very prevalent in the Fed space. It's also prevalent in a lot of the commercial space. But I'm not going to do that here for a lot of different reasons, sensitivity and things. I'm just going to play a video. So I'll start on the traditional side. And what's going to happen is what you're seeing in the middle, it says total. You see the frame count going up. And then right underneath it, you see dropped. And well, that's going up too. In fact, it's going up a lot. Right, we're almost dropping every single frame. And from just playing the video, you can see that it's jerky, and again, we put the math in here because sometimes just Teams and Zoom or whatever it is going to create that anyway. But the idea is that now I'm showing you how, a traditional approach to working with remote video is problematic, right? let's do the same thing over here on the vicinity side, right? I'm gonna make it a little bigger again. You can see the math, dog ears is what they call it, that I've turned on. And I'm gonna go ahead and play. And there we go. You might drop a frame or two, but in this case, actually it's not, right? So we're pretty good, right? I'm able to now do things with remote, in this case, video, that I wasn't able to do from before. And this is a cloud-based app essentially playing a video that's 3,000 miles away without dropping a single frame, right? Imagine the possibilities of that from an analytics perspective, right? We're really showing you the possibility of doing different things in a way that I don't even think was possible before, okay? So I'm going to finish up here and we'll open up for some questions, right? Here's really what this is about, right? We talked about stuff in the beginning. What are the three drivers that we need to work with to really grow and succeed in this AI world? It's one, how do I get data into the model to train faster? How do I get more diversified data, larger data sets, right? Which ones are the correct ones? I don't know. Let's pull them in. Let's see what happens, right? I need to get information into the model faster. I've shown you how we can do that through the demonstration, right? The second piece is, okay, how do I augment what I already trained so that my tank doesn't look like a cat? Right? It's this idea that I want to bring in tunable data. I want to bring in real-time pieces. I want to polish this model with remote information in real time to do things like RAG to really reduce hallucinations, right? I'm showing you how we can do that with an application that was running remotely in a cloud against data on-prem. But again, there's a lot of different ways to put this together. And three, the resource agility, right? That continuous data pipeline that we talked about, which says, okay, I could pick, let's say you want to use a cloud, pick the cloud of choice based on performance, cost, capability, but don't be locked into it. If I don't have to put my data there, I'm not locked in. Maybe I want to use a different cloud or a combination of clouds to do different things against data that's still in my core or data that's being created at the edge. Now I have the agility to say, okay, one, pick the resource of choice against the data that I want. Two, have no vendor lock-in. And three, I have this option to say, do I want to just move data really, really fast? Or do I want to augment it as well? It's really up to you. That's what we've provided here. So hopefully it made some sense, right? We're showing you some best practices on AI that help you hopefully, grow your environment so that you're set up for the next things like distributed or nested AI and some other stuff. Okay. So that being said, I appreciate everybody's time. Katie, I'm going to go ahead and turn on the video. And if you want to see if there are any questions on there, we'll go ahead and walk through some of them.
Perfect. Thank you, Steve. All right, my first question I have, how do you make sure the right training data is accessible? And are there any extra security factors that need to be taken into account when using or tuning data from the edge?
Okay, so three questions in one. Yeah, okay, cool. Yeah, so how do I make sure that the right data, that's really hard. That's a hard question. The only real answer to that is, have access to lots of data to see what works and what doesn't. I mean, there is some where, for example, we talked about, complementing edge analytics, right? I'll give you an example. One of the things that we've seen is you can say, okay, I want to do edge compute analytics so I can filter the data because this is what I think is important for this edge. And then over here at this edge, I think I want to filter based on this. And I can do all that. And then I'll pull the results back to kind of the AI mothership so that I can then run my AI and hopefully get good results, right? How do I, ensure that I'm getting the right data? Well, that's part of it. But here's a different approach. Is what we've seen is instead of looking at each edge by itself and running each edge independently, if I can view all of the data at one time, now I might be able to find commonalities or different things to filter that apply to everything as opposed to each one that I might have been missing in the beginning. So, can the technology itself by itself help solve what data is appropriate? No, but can it help in conjunction with other things so that I'm gathering more data, a larger plethora of information to pull back? Yes, right? Is it right or wrong? I don't know. I got to look at the data first, right? The more data I can look at, the more we can help that problem, okay? The other thing is the security piece, right? We can encrypt data in flight. We don't want to break the paradigm of locks and all that kind of stuff, but think about it a different way. Think about the fact that, well, maybe I have data that's at a remote location that I really can't move out. I can look at it. I want to be able to use it, read it, but I can't make a copy of it and pull it out. There's security, there's sensitivity, especially data sovereignty issues, right? If I have an alternative which says maybe I can just use it where it sits rather than have to take the time, the penalty, the risk associated with moving copies of information out, then I've increased my security posture and I've made that data set less risky because I'm not moving it, right? And I'll add a little bit here. Think about this is, I always tell folks, if you have 5 locations where you need to move data, have different AI algorithms, whatever it is, different users want to do something with it. Traditionally, I make 5 copies and I put one in each location. And think about what just happened. One is I have 5 times the amount of information moving out of the network, so I have a network increase. 2 is I have to have 5 times the storage footprint to make it sit somewhere. 3 is, from a security perspective, the more copies I have, the larger the attack vector, right? And that is a major security piece. The bigger the data set, the more chances somebody's going to get a hold of something with it, especially if there's a lot of copies, let alone the whole data management piece. So, and that was a little bit of a long answer, but it's really this marriage or combination of a lot of different things put together that allow us to, 1, maybe use the right data, find it, and 2, keep it secure. So there you go. Good question. I like that one. I wonder who that came from.
And that was a good one. And that was a great answer to a very complex question. All right, my second question I've gotten. So getting an AI program up and running is very hard. How can Vicinity help my AI program scale?
Yeah. Oh, interesting. Okay. So a couple things about that one. Think about the tools, right? Look at it from a tool set perspective, right? There's a lot of different tool sets out there. Think about the cloud, right? If you actually type in AI when you get in the marketplace, there's 1,000 different software programs, and some of them are similar between clouds, but some of them are not. Some of them are very unique to individual cloud platforms. And part of, how do I scale my AI is finding the right tools to use. And one of the things we want to make sure, we talked about this, we don't want to have vendor lock-in or cloud lock-in. I want to be able to use the resource of choice. Maybe it says, okay, I want to scale my AI because I want to be able to leverage this new tool that came up in this particular cloud. If I don't have to make a copy of the data and pay for it to get in there and move it and store it, then I can scale more quickly because I'm able to leverage a different brand new thing that just popped up somewhere else, which is different than where my normal stuff is residing, right? So there's one thing associated with that. 2 is, think about, one of the biggest ways that you scale something is you just feed it more data. And it's pretty straightforward stuff, right? Like give it more data, I can scale it, right? And that's really what we're about is having that reach, that ability to, we used to take months to move data, and being able to do it in, a lot faster time frame. It's kind of funny, and we see it in the commercial space as well, but in the Fed space, people are still moving stuff around on hard drives and airplanes and FedEx and stuff. It's insane with the new technology that's out there. So, how do you scale? Well, I think those are kind of 2 examples of that. Yeah, good question.
Yeah, no more dinosaurs.
Cool.
This question is pretty straightforward. In really simple terms, how does Vicinity directly impact AI at the edge?
Oh, at the edge. Okay. So, as an edge platform itself, not so much. But again, you don't want to have just an edge platform sitting there all isolated by itself, right? If that's what it is, then you can do AI. Within an environment, and I have a compute platform there, and I'm able to do AI for that particular piece. That usually isn't something that is prevalent in the federal space. It's usually multiple locations, multiple edges, all leveraging that information together. So, having that reach, having that ability to have a very geographically dispersed architecture that is doing edge AI, but then I can pull essentially the results back. That's where the power is. For example, State Department, I was on call not too long ago, State Department, 288 different locations, right? I'd like to do some AI at the edge. There's a lot of information that's occurring in each one of these countries, but I want to pull it back to do other things with it as well, right? I don't want to just create an edge platform that's all by itself, right? It's like giving somebody a cell phone and then not being able to turn on the uplink. It's like, okay, you got a cell phone, you can run some apps or use your calculator, but you can't talk to anybody. There's no value in that, right? So we can kind of empower these edge cell phones per se, so that they can connect back together. That's where we're adding some value. That's where I think the industry's headed. Yeah. Interesting question.
Yeah. Great question. All right. Second to last question, I swear. I will let you get out of here. How can I ensure my data is secure using Vicinity to move my data into the AI models?
Okay. So a couple things, and this is a little bit of what we've discussed earlier, which is, in some cases, if I don't have to move the entire data set, I can just use it where it sits. There's immediate results there from a security perspective, right? or even being able to just look at the data, right? Some people say, well, you can't move it. If you can't move it, you can't look at it. So sorry, you can't use that data set. The other piece is you want to make sure that, I can encrypt that data in flight. And the interesting part is a couple of things. One is because we don't look at the data, right? It's just bits. Okay, we're not compressing data, anything like that. I don't care what the data set looks like. So from a security paradigm, the data could already be encrypted, right? So if I'm encrypting my data at rest, great. Doesn't matter to us. We don't look at it anyway, right? We're not going to break that paradigm. And then two, we can also encrypt in the middle. And, we play with type 1 encryptors from a Fed space. There's, this is advanced encryption stuff, right? Aside from maybe the movie industry, keeping track of who's got what pieces of data and making sure that it's secure and encrypted. The Fed guys are pretty good at it, right? So this is an interesting thing. So again, it's augmenting the encryption that's out there, not breaking it. And then two, providing extra pieces in the transfer of information itself, whether it's the larger data set or that access, the remote access, because you got to move a little couple things, but they're just memory and it goes away. So yeah, that answers your question. I'm sure that came.
Yeah. No, totally. I think that's what makes people love us so much too, is how flexible we can be with their data. If you don't want us to touch it, we won't. If you want us to, yeah. So I totally. Cool. This last question is kind of a curveball because it's from myself, but I was thinking of something we could try to cover. We're seeing that legacy technologies, old approaches to increasing data transfer efficiency over the WAN, including WAN optimizers, edge caching, and extreme file transfer products, are becoming a little less impactful at every network echelon and throughout the entire data lifecycle, really. So, Steve, my question is, how is Vicinity helping these organizations upscale those technologies while, one, not complicating the legacy systems that they already have in place, and then two, deferring those sunk costs?
Sure. So, wow. It's supposed to be one question. There's like 10. All right. No, it's fine. I'm just kidding. So a couple of things, right? If you think about the WAN up folks and the great technology, back in the day, it's a little dated, but there was a place for it. They're good companies. But I think that, things have changed a little bit, right? The manipulation of data to create faster movement is no longer, I think, acceptable. It's just becoming more and more relevant that pristine copies of data are the way to go. Two is, and I don't want to get into cost, but some of the cost structures, business models of, hey, I can move data, but you got to pay so much per bit kind of thing. That's problematic because guess what? You're moving a lot more data. It's no longer terabytes, it's petabytes. So the business models of some of those kind of legacy technologies should be something to consider. With our approach a little bit different. The other thing is, if you have to predict what you're doing ahead of time, that could come into be a problem, right? And if you think about some of the intelligence of caching kind of technologies where we'll look at usage patterns and kind of figure out what's going on, and then we'll move that ahead of time and try to get a head start, right? And that's okay, except when my data is too big, because then I'll get it in time, because remember, there's perishability. Two is, what if I guess incorrectly? Or three, what if my data changes too frequently, right? So, good technologies, they had their place. Again, I'm not here to beat anybody up, but I think now in the era of I need real time, I can't have any manipulation of the information, and the scale of it, from a cost or business structure is massive. All of a sudden, you gotta have a different approach, right? So I think that's where somebody like us, complementary with other companies that we partner with, can do some unique things in the industry. So, hope that answered that question.
It did. Thank you. I know we're running out of time, so I'm just going to wrap things up here. Thank you so much, Steve. For everyone else, if we didn't get to your question, or if you have any additional questions, please reach out to your Vicinity sales rep. We will also be sending out a recording of this session, so feel free to reach out there as well. Thanks again, Steve, and thank you to everyone on the line. And with that, we will close. I hope you all have a great day.
You as well. See you guys.